Okay, here we go. Question 3, part B. And I'll let you pause that and read that if you need to, otherwise I'll crack on. So I guess we've got to decide here what sort of probability distribution we're going to use. And it really comes down to this idea of the shirt being defective. And so that gives us two outcomes. So we have two outcomes. A shirt is either defective or not defective. And so because we have two outcomes, we're going to be using binomial distribution. Okay, so we're told that the probability that something is defective is 0.04. That's just from the question. And the question is asking for us to find the probability that there will be at least two shirts in defective shirts in the order. So the question is asking for the probability that X is bigger than or equal to 2. And that's going to be the same as 1 minus the probability that X is less than or equal to 1. Okay, now in this problem, the number of trials is 20 because we've got an order of 20. And our X that we're working out is going to be up to 1, so less than or equal to 1, and our probability is 0.04. And so those are the variables that we're going to have to put into our calculator. Okay, so let's bring up our calculator if we can. So let's get that, there we go. Can't get that calculator coming up. There it is. Okay, there's our calculator. Okay, so let's put in those things. So going into distribution mode, and we're doing binomial, B, C, D, and variable, and X we're going up to is 1, number of trials is 20, the probability is 0.04. and that's our probability, 0.8103. So let's write that down. So we've got 1 minus 0.8103, and that gives us 0.1897 for our final probability when we subtract it away from 1. So now it's asked for our assumptions and us to justify ourselves. So we'll just do that here. Assumptions and justification. Okay, so one assumption that we're making is the probability of any shirt being defective is remains constant. So prob of defective shirt is constant. So in other words, any shirt has the same probability of being defective, and also events are independent. So in this case, that means that one shirt being defective does not affect the probability of another one. Okay, and that's that question. Now I think we might just crack on and go into C straight away. So once again, I'll let you pause here and read if you need to. But the gist of the question is to see if our customer here has any right in saying that this is unexpected. So we're going to use binomial to check this as well, because we've got two outcomes, facing up and facing down, and so the probability should be, if it's facing, that it faces up, should be 0.5 if it's fair, and the number of trials that the customer did was 20, and our x value is 13. Now whether we put 13 or 7 in doesn't matter, because we're either looking at face up or face down, and because they're supposed to be 50%, we'll actually end up getting the same probability either way. Let's look at the probability that x is, we'll say, less, well, bigger than or equal to 13. Well, what might be easier in that case is to say smaller than or less than 7. Okay, so let's put that into our calculator using PCD. So we'll get the calculator back up. Okay, so this time our x value is going to be 7. Number of trials is still 20, but our probability is 0.5. There's our probability, 0.1316. So 0.1316. So really we've got to say whether or not that probability is reasonable. And if you think about it, that's a better than 1 in 10 chance. So it's quite possible that when the customer did their test with only 20, that they just happened to get this because, well, that's better than 1 in 10, it's nearly 1 in 6. So that result is actually relatively common. So what we'll say here is, since the prob of this result, or worse, so having an even bigger difference, is around 0.1316, the customer would need to do more trials. Before they could make an assertion, and so therefore the complaint's not really justified at this stage. So therefore the complaint is not justified. And that's all we really need to get into there. Okay, there we go.